All right, this 10.3 says further identities. Now, they're going to put a whole lot of identities in here that we are not going to cover because frankly, they're not important enough to cover. So we're just gonna swing past those, but there are a few that we do need to know. So here are memorizers. Double angle identities. So these double angle identities. Cosine has 3. Crazy, right? If I have cosine 2a. Now they use a instead of theta in your book, so we'll just go with a. It doesn't really matter. Cosine 2a. Now notice the difference here. This is a double angle, meaning this is 2a, double that angle measurement. This is not squared, right? This actually equals cosine squared a minus sine squared a. So notice the difference here. This is a double angle. This is an exponent. All right? Okay. The other two for cosine are a little bit more interesting because we use those. So cosine 2a is now equal to 2 cosine squared a minus 1. And the last one for cosine double angle here is going to be 1 minus 2 sine squared of a. Now, this one and this one can be manipulated. I call them power reducing formulas. And you are going to use these like you've never used them before in Calc 2. Because whenever I'm looking at these formulas, you're going to do a lot more trig. That's going to come back in Calc 2. We're going to do very little in Calc 1, but a little bit. Your Calc 2 is where you're going to see the most of your trig. So cosine squared a is going to equal 1/2 of 1 plus cosine 2a. And sine squared a is going to be 1/2 1 minus cosine 2a. All right. These you have to memorize. These over here, I mean, if you know them, great. If you don't, I don't really care. But you need to have these power reducing, those are important. So you have to do that. Now let me prove to you how we pull this off. I'll just do this one because it's on the bottom. So what I'm actually doing here, if I have cosine 2a, remember how we've talked before of any of these formulas are legitimate. Sometimes it's just a matter of algebraically manipulating them and to get them into what you want, and that's what's happening right now. So I'm just going to isolate this sine squared. So I'm going to subtract 1 from both sides. And I have cosine 2a is equal, minus 1. I can't forget that little fella, can we? Negative 2 sine squared a. So I'm going to divide everything by this negative 2. When I divide by a negative 2, I'm actually going to write it like this. I'm going to times this by a negative 1/2. Now, when you distribute the negative sign here, this negative sign that's distributed makes this one negative, and I distribute it makes that positive, right? So what we really have here is this 1/2, 1 minus cosine 2a is equal to my sine squared. Same thing. All right? So that's the same thing. And we're going to use it in this form. So your calc book talks about it as a double angle identity because they use it in this form, and it's just a manipulation to get there. Different books call these power reducing and call them separate forms. They're literally the same. It's just a manipulation. But this is the format that we're going to use them in calculus. This is the format that you're going to use them in trig. All right? So you need this for calculus. You're going to use those in Calc 2. These you're going to use in trig right now. All right, so it'll be in this form over here for trig, so don't lose those. But these are what you actually need to memorize to use for future, is what I'm getting at. All right? Okay, I think I've belabored that one enough. Okay, one more that you're going to have to memorize is double angle sine. Sine 2a is equal to 2 sine a cosine a. This is also a memorizer, so I should have stuck this up here with this. Memorize this one too. I actually take this off. Oh, for crying out loud. Because you are going to use this again in Calc 2. All right, so we use both of these, the power reducing and this double angle sine, a lot in Calc 2. All right, the rest of this stuff is awesome, but you're just not going to use it that much other than in trig right now. Tangent, again, is a rational expression. To tangent A over 1 minus tangent squared. That's a tangent squared. That's an exponent. All right? Double angle exponent. Okay? Okay, so now let's do this. So here's how you're going to see these kinds of problems. I'm going to scoot on over here to the next page. We are going to have something like here in this example 1, where I am given that the cosine of theta is equal to 3/5. Sine of theta is negative, so less than 0, and I need to find double angle sine, double angle cosine, and double angle tangent. I have to find all three of those. All right? So let's do it right now. The fact that this is negative, your sine, I shouldn't say this, I should say what it is. Your sine is negative. When you do this right triangle, because you still know that this is x over r, right? So you know that this is a triangle. When I have my triangle, my x value is positive. R is always positive, right? That I have here. My y value here is negative because sine is negative and this is a 5. So do you guys know a common Pythagorean triangle? Yeah, it's a 3, 4, 5 triangle. You can also use Pythagorean theorem in order to come up with this, but this is just a common 3, 4, 5 triangle. So anytime you see that, you know that that's what that common triangle is. So you can work at this and say, oh, I've got 3 squared plus y squared is equal to 5 squared. So y squared is now equal to 25 minus 9. Y is equal to 4. And I know that this one is negative just because it tells me that it's negative in my problem. Otherwise, it would be positive, but because it tells me it's negative in my problem, so there's my x, my y, and my r. All right? So, if I have sine now, so I know for my formulas, I'm going to flip back real quick. For my formulas here, I need to know sine and cosine, depending on what it is I'm looking at. I have to know both sine and cosine for the sine. I can know sine and cosine, just the cosine or just the sine for cosine 2a because it's all the same. But I also need to know tangent. So when I'm setting this up, I'm going to go ahead and just write these out just because it's easier. I know that my sine here of theta is going to be 3/5. I'm sorry, cosine, because that's what's given to me. My sine, because I figured it out, is going to be negative 4/5. And tangent, because it is sine over cosine, or opposite here of my theta over adjacent. Theta, right? Opposite over adjacent will be negative 4/3. So if I want to find sine 2 theta, you literally plug into that formula. Sine 2 theta is equal to 2 sine theta cosine theta. And that's one you need to know. So 2 times my sine, which is -4/5, times cosine, which is 3/5. You're literally just plugging it in. All right? You do that multiplication, and I've got negative 8 times 3 is 24 25ths. There's your sine 2 theta. Then we just do tangent and cosine. For cosine, you can do whatever the heck you want. You've got 3 choices for cosine. Let's change up our colors. So if I have cosine 2 theta, you can do whatever you want. I'm given cosine up here, so we might as well just use that cosine formula, where it is 2 cosine squared theta minus 1. So 2 times 3/5 squared minus 1. 2 times 9/25 minus, and I'm going to go ahead and get my common denominator. So I have 18/25 minus 25/25. So I know that the cosine of 2 theta is now equal to a -7, right? Yeah, -7/25. Literally, once you figure this part out, then you just plug this into the formula. That's it. And cosine, you can do them. So try on your own. Try all of 3 of them to see if it all plays out. And you'll see that they all do play out. Lastly, we have tangent. So our formula for tangent would be 2 tangent theta over 1 minus tangent squared of theta. I'm going to scoot this up just a little bit and just keeping that tangent there. So the tangent 2 theta is equal to 2 times -4/3 over 1 minus a -4/3 squared. So when you square a negative, now I'm going to scoot this up more. When you square a negative, then it's positive, right? So now I end up with -8/3 over 1 minus 16/9. If you get that common denominator, giving you 9/9, then you end up with a -8/3 divided by a -7/9. When you multiply by the reciprocal, first of all, negative divided by negative is positive, so I'm not even going to mess with that negative sign. You have 8/3 times 9/7. 3 goes into 9 3 times, and we end up with 24/7. That is our double angle tangent. All right. Literally plug into the formula. The biggest thing here is you take the information that you are given. With this information given,